Hi, welcome to our next video. This video will cover questions 12, 13, 14, and their subsequent subparts. So let's start with question 12. Question 12 reads, sketch out the electromagnetic spectrum. Include X-rays, microwaves, gamma rays, UV light, IR light, visible light, and radio waves. Then it's asking us to show the frequency of electromagnetic radiation as it goes from low to high across the spectrum. Show how the wavelength and electromagnetic radiation goes from long to short across the spectrum, and how the energy of electromagnetic radiation goes from low to high across the spectrum. So I'm going to do it from high to low. So then it gives me a list of radiations to note. So I know that my high frequency the dangerous one, the one that gives me cancer, is called gamma. I also know that gamma rays have a short wavelength and high energy. So gamma rays have a high frequency, which in turn causes it to have short wavelength, and the short wavelength and high frequency equal high energy. And I know this because gamma rays can give me cancer. The next one in the list would be X-rays. The next one would be UV, ultraviolet radiation. There you go, UV. Then we go to visible light. After visible light, we have infrared. Then we have microwave. And lastly, we have radio waves. Radio waves have low frequency. They have long wavelengths. And low energy. Part B asks us to sketch out 13 asks us to sketch out visible light spectrum and label its colors. It wants us to show the frequency of electromagnetic radiation as it goes from low to high across the spectrum, and how the energy of electromagnetic radiation goes from low to high across the spectrum. So let's do energy from low to high. So my low frequency would be the one with less energy. So using my previous diagram, I know that infrared has lower energy than ultraviolet. I know that red and violet are the cutoffs for my visible spectrum. So I know that low frequency with low energy is my reds, and then I would have orange, then I would have yellow, oh, it's misspelled yellow, then I have green, and then I would have blue, indigo, and violet. Now I know that indigo is no longer in the color spectrum, but let's just put it there. And you can notice that it spells out Roy G. Biv. So violet has high frequency, high energy. And this matches. Here we have ultraviolet radiation towards the more energy, higher frequency, shorter wavelength versus the low frequency, low wavelength, low energy reds. You should also note that the frequency for the red for the violet causes a high frequency causes a low wavelength, so visible light goes 400 nanometers. So from 400 to 700 nanometers in wavelength, and you should know that number. Alright, that's 13. Let's do 14. 14 asks us to perform the following calculations. What is the frequency of electromagnetic radiation with a wavelength of 1.5 times 10 to the third nanometers? Well, I don't know. I don't even know my formulas. Good thing I have my conversion chart. And here I have atomic structure formulas. And the atomic structure formulas will give me some equations. So this is asking me to look for frequency, and it gives me wavelength. Well, frequency and wavelength really only occur here, and this will give me the speed of light. But I don't know the speed of light. Where can I look? Oh, it's in my constants. I'm so lucky. It's like someone planned this and made it just for me. So let's look at our equation where I have C equals V lambda, or lambda V, whatever, it's the same thing. So here we go. I have C, that's the speed of light. I always have the speed of light. And I want to find the frequency. So frequency is the V. So I need to get the V alone. Well, I can divide by the wavelength. So I can have the speed of light divided by the wavelength would equal me the frequency. So I can have 3.00 times 10 to the 8 meters per second divided by whatever the problem says. The problem says 1.5 times 10 to the negative 3 meters. So then my answer will be in hertz or per second. It's the same thing as hertz, just frequency. The meters will cancel out. So that was A. Let's do B. B reads, what is the wavelength of electromagnetic radiation with a frequency of 2.8 times 10 to the 15 hertz? Well, I'm probably going to use the same equation. C equals V lambda. I need to find wavelength. So I'm going to do the same thing, just opposite. I'm going to divide that by frequency now. Divided by frequency. So I'm going to the speed of light divided by the frequency. It's going to equal the wavelength. So I have 3.00 times 10 to the 8 meters per second divided by the frequency that this problem gives me, which is 2.8 times 10 to the 15 hertz. Remember that hertz means per second, so per seconds are canceled out, and I'm left with meters. That should be the wavelength. And finally, what is the energy of electromagnetic radiation with a frequency of 5.9 times 10 to the 16 hertz? Well, I haven't done a problem with energy, so let me look. Maybe I need to change my equation. Here I have two equations that require energy. And the problem asks me for what is the energy with a frequency. Well, I have frequency right here, but I don't remember Planck's constant. Maybe it'll be here. There it is, 6.63 times 10 to the negative 34 joules second. So let me now use this new equation. So C has the equation that the energy is equal to hv. H being Planck's constant and V being the frequency. And I don't have to modify my equation, so I can just plug in Planck's constant, which is 6.63 times 10 to the negative 34 joules second, and multiply that by the frequency given to me, which is 5.9 times 10 to the 16 hertz. Hertz, remember, stands for per second, so I'm actually dividing by second, so I'm going to end up with joules. So I just multiply these two and end up with joules. Remember that if I'm multiplying with exponents, I can just add the exponents, so I have negative 34 plus 16. That'll give you an answer. Alright, I hope this was helpful.